This is a study on the linear technology 0.4 gigahertz to 2.7 gigahertz high linearity upconverting mixer. Welcome to the training module on the LT5578. This training module introduces the 0.4 gigahertz to 2.7 gigahertz frequency upconverting mixer device and its typical applications. The LT5578 mixer is a high-performance upconverting mixer optimized for frequencies in the 0.4 gigahertz to 2.7 gigahertz range. The single-ended LO input and RF output ports simplify board layout and reduces system cost. The mixer needs only -1 dBm of LO power, and the balanced design results in low LO signal leakage to the RF output. The LT5578 offers a high-performance alternative to passive mixers. Compared to alternate passive mixers, more than 8 dB of conversion loss, the LT5578's 1.4 dB conversion gain produces 9 dB higher signal power without the need of an external high-power, high-linearity RF output amplifier stage. The LT5578 is designed to satisfy the requirements of next-generation LTE wireless base station transmitters and improves the performance of wireless equipment including WCDMA UMTS, TD-SCDMA, CDMA 2000, CDMA, and GSM/Edge base stations. The mixer is also ideal for a wide range of communication gear such as cable-headed end transmitters, microwave broadband transmitters, wireless repeaters, military radios, digital video broadcast systems, 2.4 gigahertz ISM band transmitters, test instrumentation, microcell and picocell base station applications. The LT5578 operates from a single 3.3 volt supply. Typical quiescent supply current is 152 milliamps. The mixer has 1.4 dB conversion gain with integrated RF balun transformers that provide a single-ended RF output and local oscillator input to simplify designs while reducing external component count. Moreover, the device's local oscillator input is internally buffered, requiring a drive level of only -1 dBm. This results in an outstanding local oscillator to RF leakage of -43 dBm. The IF input is differential. The LT5578 is intended for operation in the 0.4 gigahertz to 2.7 gigahertz frequency range. The purpose of the inductors, L1 and L2, is to reduce the loading effects of R1 and R2. The impedance of L1 and L2 should be at least several times greater than the IF input impedance at the desired IF frequency. The IF inputs are tied to the emitters of the double-balanced mixer transistors. The optimum DC current in the mixer core is approximately 40 milliamps per side and is set by the external resistors R1 and R2. The inductors and resistors must be able to handle the anticipated current and power dissipation. The simplified schematic for the single-ended LO input port is shown in this page. An internal transformer provides a broadband impedance match and performs single-ended to differential conversion. The primary winding is internally grounded. Thus, an external DC block may be necessary in some applications. The transformer secondary feeds the differential limiting amplifier stages that drive the mixer core. The measured return loss of the LO input is plotted in this page for different application frequencies. The impedance match is acceptable from about 1.5 GHz to beyond 3 GHz with a minimum return loss. An internal RF transformer reduces the mixer core output impedance to simplify matching of the RF output pin. A center tap in the transformer provides the DC connection to the mixer core, and the transformer provides DC isolation to the RF output. The RF pin is internally grounded through the secondary winding of the transformer, thus a DC voltage should not be applied to this pin. The application shown in this page has a wider bandwidth than the 740 MHz and 900 MHz configurations. Using two additional components at the RF output allows the bandwidth to be extended to cover the range from 700 MHz to 950 MHz. Figure 11 compares the broadband return loss to the typical 740 MHz and 900 MHz return loss performance. The LT5578 was evaluated for an application with an IF input of 70 MHz and an RF output of 450 MHz and a high-side local oscillator. The local oscillator port is tuned for high-side local oscillator injection at 520 MHz. At the IF input, the 560 picofarad capacitors are used mainly as DC blocks, but also help to tune out the parasitic inductance of the transformer. The 82 picofarad differential capacitor and 3.3 nanohenry chip inductor provides an impedance transformation between the IF input pins and the transformer. This page gives typical performance characteristics for the 2600 MHz application. The measured room temperature performance is plotted for both low-side and high-side local oscillator drive. At 2600 MHz, the gain is approximately minus 2.8 dB with a noise figure of 11.2 dB and OIP3 of about 22.2 dBm. Low-side local oscillator yields slightly better overall performance than high-side local oscillator. The second curve compares the broadband return loss to the typical 740 MHz and 900 MHz return loss performance. This page shows the evaluation board details for the device LT5578.